We balance an equation, we can't change what this is. If I change the ingredients of mac and cheese, I'm not going to get mac and cheese, okay? All we can do is we need the right amounts, right? That's what we're doing. So when we balance today and we'll learn how to do this, you're going to see that the numbers I write are always going to go out in front. Okay, you can never, ever, 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 ever change a subscript because that changes what it is. Can somebody by raise a hand explain to us what's the difference between saying two O2s and me saying O4? What's the difference there, Gavin?
So the two O2s is like, there's an O2 over here and an O2 over here. And O4 would be 4 oxygens all bonded together.
Very good, right? This is 2 sets of O2. That exists. O4 doesn't exist. Oxygen doesn't bond in 4s altogether, okay? So in order for this to be balanced, right, we end up with needing a ratio for every 1 methane, that's what this is. We need 2 molecules of oxygen, and then in result, we end up with 2 water molecules in relationship to every 1 carbon dioxide. Okay, and this reaction would not happen if I only had 1 of these and 1 of these, the reaction would not go. It needs the right ratio in order for it to work out. Okay, so I'm going to do this demo for you in real life. So, okay. Yeah, I have to pick somebody I trust to light my hands on.
That didn't.
Balancing reactions, like we said, it goes back to the law of conservation of mass. That mass is neither created or destroyed in a chemical reaction. All it is that the atoms get rearranged. Okay? They change places, they change partners, but what was there in the beginning must be there in the end. Okay? So let's say, for example, and this is another one I hope to be able to do as a demo one day, but if you take water, right, some good old H2O, and you send electricity through it, it's called electrolysis, you can cause water molecules to split into hydrogen and oxygen gas, right? So notice how the atoms, like originally, the hydrogens actually aren't even really bonded together, right? They're bonded to the oxygen, but once the electricity gets sent through it, they break off and come together, and then the 2 oxygens come together as well. But the same amount that is here is over here, okay? So as we're learning to balance chemical reactions today, I'm going to show you 2 different methods you can use. One is a more visual method, one is a more mathematical approach. And this is one of the few times where I'm really going to say, as long as you're getting the right answer, I don't care if you show work for balancing. I really don't. The one thing I'm going to say is if you do keep getting the problems wrong, I'm probably going to encourage you to start showing work because there's something that's not working out. So once again, we're going to start with some good old H2O, right? And I'm going to split it, and when it splits into oxygen and hydrogen. So why am I not balanced here?
Just need 2 of the H2Os.
So the problem right now with how it is there's only 1 O on this side, and there's 2 on this side. Why does this have to be a 2 though? Why can't it just be 1?
Because it's diatomic.
Yeah, oxygen is diatomic. It doesn't exist as a single atom. There's actually no possible way for you to split just 1 water molecule. It won't happen because that oxygen always needs a buddy. So like Gavin said, all right, well, in order to balance this, we need 2 waters. Woohoo! Uh-oh.
Dang it. You need more hydrogen.
So then in result, by adding more to this side, right, now there's 4 hydrogens over here, so then there must be, all right, moment of truth. A little help. Ta-da! Right, and then it becomes balanced. So you're going to see today that as we balance equations, focus on one thing at a time. Do not try to fix the entire world at once, right? You got to fix the world one step at a time, okay? And a lot of times as we're balancing today, you're going to see that you're going to go this way and this way and this way and back and forth, and then eventually it will level out. Okay, sometimes your problem's gonna look like it's getting messier before it gets balanced, and that's okay, because that's just kind of how the process works. Okay, so here are steps in balancing a chemical equation. Step 1 is we need an unbalanced equation to start with, right? So if it's in word form, we do have to change it into symbols to get it to work out. Okay, step 2 is you're going to count the atoms on each side. Okay, you need to know what you're working with so you can figure out what's balanced. You may find when we start working on our assignment today that some of the equations are already balanced the way they're written. They don't need any other numbers to fix them, and that means it's easy for you. Okay? The third thing you're going to do is we add the coefficient, which is that big number out in front, to make the total number equal. Okay, sometimes you may get a little carried away with your balancing, and your numbers might be bigger than they need to. In that case, you do want to reduce if possible. Like, let's say, for example, on the last one we just did, if you finished balancing, and it looked like this in the end, what can I do with all those numbers?
Divide them by 2.
Yeah, divide them all by 2. So if they're all reducible, reduce them. But they all have to be. You can't just reduce 2 of them, because then it's not balanced anymore. Okay? So that's just, if it happens, make sure it's balanced. And then the last thing, step 5, is you should be able to check your answer because you already know the answer. Kinda. The answer is that it should be balanced, right? If it's not balanced, are you done? Nope, you gotta keep going. And if it's balanced, unless you messed up mathematically, it should be correct. Okay? Another thing I'm going to recommend as you're balancing today is if you are ever doing a problem and you kind of get stuck, like you just keep going back and forth and your numbers just keep getting bigger and bigger and it's not working out, sometimes the best thing to do is to erase and start from the beginning. Because sometimes if you made a math error in the beginning, it can lead you down the wrong path and you'll never find your way back. So you just need to go back to the beginning and restart sometimes. Because, yeah, little math mistakes can sometimes mess you up. Okay, so let's do this one together. I'm going to show you, like I said, 2 methods. One method that some of my students like is they like the visual method of kind of what your intro assignment was on, where you can use like shapes or colors to help you see what's going on. Right? If you don't like that method, that's fine. Write it down for now, but you don't have to do it. Pick whichever works best for you. Okay? So I'm going to say, let's say my aluminum's going to be a square. And my chlorine, let's make a triangle. So it's AlCl3. So that's a grouping, right? There's for every 1 Al, there's always 3 Cls. Let's go, our Na will go circles. So for every 2 circles, we need 1 sulfur, which I'm going to go as a star. Okay? Another method my students like to use last year, which is maybe a little less, doesn't take up as much space, instead of drawing shapes, is actually, I have markers that you can use, and they would just do dots on their paper. So they would just do, okay, aluminum's purple, so they do 1 purple and then 3 greens, which is a little bit faster and less space than drawing shapes. But once again, just do what works for you. Okay, now we gotta go to the other side, same thing. So aluminum is our square, so we need 2 squares for every 3 circles. Oh no, stars. That's a star. Okay, and then we have Na and Cl. Circle and triangle. Okay, so some people as a visual learner, it helps them to kind of see, looking at this, well, I can see right away that nothing is actually balanced, right? None of the shapes are the same on both sides. So my next thing I'd recommend, once again, is pick just one thing to fix. What shape do we want to fix first?
Als, you need 2 on the left side.
Good, so there's 2 boxes over here, so I need another box here. The thing to remember is that when I put a box, what has to come with it?
Triangles.
3 triangles, right? Because the AL is in a set, there's no way to just add an AL. And yes, I understand that that makes it messier. Like we said, it just happens.
So how do you
Yeah.
not, what if it's a square and 3, oh wait, never mind, I got it.
You good? Okay. All right, so we fixed our squares. Those are balanced. Let's fix stars.
Let's do triangles.
You want to fix triangles?
Because you have 6 on that side, so you just need 6 over here.
All right, so we can fix triangles. So we have 6 over there, so we need 6 here. 1, 2, 3, 4, 5, 6. And with every triangle comes a circle.
Then you can fix the circles on the other side.
Okay, so if I have 6 circles, sorry, I'll give you a second to draw those out.
Oh, do you?
So the circles, they come in sets of 2, right? So I need 2, 4, 6, and with every circle comes a star, and that fixes the stars as well. Yeah.
I'm confused. So there's 6. Oh, so you don't put. Okay, never mind.
No, you're good. You're good. Any other questions right now? Okay, so if you're using the picture or the visual method, once everything balances out, then what we do is on the lines up above, and I think you need to draw yours in on your notes. Okay, the lines up above is where you put how many you have. So on this line right there, you put a 2, because you have 2 ALCL3s. On this line, you'd put a 3. What would I put on this one?
1.
A 1. Normally there won't be anything there. I'm going to ask for this assignment that you put a number 1 so I can see the difference of you did a problem versus you just left it blank type thing. So do put a 1. Normally it would just be blank though. And then on this one you'll put a 6. Yep. So 2, 3, 1, 6 are our coefficients to make it balanced. And you're done. Questions on that? Okay, let's try. Now I'm going to show you my more, I guess you could say a little bit more mathematical approach. Okay, so with this equation here, another method you can use to help you balance is, once again, we still need to keep track of total how many of everything we have. But instead of drawing out shapes, what I do is underneath the arrow is make a list of every element present in the formula. So I would say, all right, so there's an aluminum, there's a copper, and there's a chlorine. So we make a list of everything that's there. And I always do it just right underneath the arrow to keep track. Okay. Then what we do is, so we look to the left and say, okay, on the left there's 1 aluminum, and on the right there's also 1 aluminum. Do the same thing for copper. On the left, how many do we have?
1.
Just 1. And on the right, also just 1. This is looking pretty good so far.
And then you get the chlorine.
And then we have the chlorine. 2 on that side and 3 on the other.
So you're going to have to multiply that one by 3 and the other by 2.
Good. So a simple trick you can use, right? First off, recognize these numbers here have nothing directly to do with the numbers we're going to write up here. These are simply a way to keep track of the totals, because the totals have to be balanced, okay? So Jeff brought up, since we look at this, right, it's a 2 on this side, it's a 3 on that side. They don't go, there's not like an easy way, right? There's nothing you can do 2 times to get 3. That's not a fraction. So if that ever is the case, we times them by each other. So I'm going to take this side and times it by 3. Because if I put a 3 there, 3 times 2 gives me a new total of 6 chlorines.
Wait, so what did you times the 3 by?
So I took, since this was a 2 and that was a 3, I'm going to times them by the opposite. So that's why we put a 3 up here. So we do 3 times 2 gives me 6. And then we're going to take the 2 on this side and times it up there. Because 2 times 3 is
Then you get
also gives
the
me
9,
6.
3 copper on that side.
Good. By putting that number there, it also affects the copper. So this is now 3 coppers,
And the aluminum.
and the aluminum is now 2.
Wait, when you say times, you're not really timesing that though, right? Like you said times 3 by 2, but that doesn't make any sense.
3 times 2 is 6.
Because this is
Yeah.
like, so we have 3 sets of this.
Yeah, so where'd you get that 3 though?
This is what we chose to put here because we needed to make it balanced.
So did you just switch the 3 and the 2 or what?
Yeah, in a sense, because since these two things don't times into each other nicely, we just switched what we times them by, so times them by their opposite.
Okay.
In this case now, so since copper's a 3 on this side, and it's only a 1 on that side, that one's an easy fix because I can just put a 3 here, because that gives me a new total of 3. And then what would I do on the other side?
2.
I need a 2 for my aluminum. Notice with my numbers below, what I like to do is I like to just cross off and rewrite. Because it's not directly always a mathematical relationship between them, right? It's just this is the new total. How many total I have now.
Wait, where'd you get the 2 from the AL?
So we knew that this side was a 2 because of that 2 there, right, that we had put already.
Yeah.
And we need it to be balanced. That's the whole trick, right? So if there's 2 aluminums on this side, we must have to have 2 on that side too.
So where'd you get that 2 then? This one.
So the numbers out in front, we are deciding what goes there. Just whatever is needed to make it balanced. Yep, so the coefficients are what you're trying to figure out to make it balance out. And really the thing is with balancing, like balancing is a problem solving process. Meaning it's not going to be the same every single time. The more you do, you'll start catching on to patterns and different things that will make it faster. But even to this day, if you give me a balancing problem, it's not like I know the answer right away. I still have to solve it out. Okay? Any general questions so far? So whatever you like to use, whatever makes most sense in your brain, I encourage you to do it that way, whether that's drawing it out or using numbers, as long as it gets balanced in the end. Okay? Here's a few hints if you flip to the back side of that paper that can sometimes make balancing go a little bit faster. One thing, like I said before, is just balance one thing at a time. Okay, don't try to fix everything. Just say, I'm going to fix aluminum, and then I'm going to fix copper. Okay, next thing is don't forget to update your count as you go. Meaning what you put a 2 out in front, remember it affects everything that it's touching. So you got to make sure you take that into account. If an element appears more than once per side, I recommend that you balance it last. I gave you an equation on there, right, as an example. I think it's this one. So if you had this equation,
No, it's H2O.
and you were trying to balance it, right? Which element, based off what this says, would you wait to balance till the end? Oxygen. Yep, in general, I would wait because since oxygen is here and here, it's in 2 different places on the same side. Wait until the end because it might just work itself out. Okay? Otherwise, it can get a little tricky if you try to fix it in the beginning because you put a number here and it changes, you put a number there and it changes, and it just keeps changing on you. Okay? And then finally, another thing you can do that will help speed things up is if there's a polyatomic, you can actually group them as one thing. Okay? So for example, in this equation, do you see a polyatomic that is present on both sides? What's our polyatomic? Yeah, SO4. A good way, often, not always, but there's lots of times if there's parentheses around something. So we can treat this like one thing. So in my counting, I'd say SO4, and I'd say, okay, on the left side, how many SO4s do I have? Yeah, just one group of that. And then on the other side, how many do I have? 3. So all that does is it just saves you the hassle of having to distribute the 3 inside. Okay? If you don't like grouping it, you don't have to. You can still do it all individually, but it does just save you a little bit of time. Okay? So let's see, I have SO4, I have a hydrogen, I have aluminum, and do I have to do another oxygen on its own?
Yes,
Yes. Why, Ben? Why can't? Because there's already oxygen here.
because if you combine that as one, there's still oxygen and H2O.
Yeah, there's oxygen that's not part of that group, so we do need it separately still. Okay?
What about the OH? Is that a combined?
Ooh, so that one is a polyatomic, but is it directly present on the other side?
Oh,
Not really. There's kind of a hidden way I can show you later where it is actually there, but it has to be on both sides in order for you to group it. So, but good observation. Okay, don't say it out loud, but show me with your fingers how many total hydrogens are on this side of our equation. Show me on your fingers how many total hydrogens are on the left. Five. Very good. Right? Because there's 2 here and 3 there, right? So that's why what I'm saying, when there's things in 2 different places, you got to make sure you take them all into account. So there's 5 on that side. On the other side, we just got 2. Aluminums, we got 1 and 2. And then oxygens, how many are going to be on the left? Show me on your fingers again. How many oxygens are going to be on the left in terms of this number we put right here? It should just be a 3.
What?
Why is it a 3?
Oh, use SO4 as the one thing.
Yeah, because this one, right, we're treating as a group. And that's something that can help is like if you want to like circle or box your polyatomics or something, right? So you kind of remember like I'm treating this as one thing, right? So we actually only have 3 oxygens there and just 1 on the other side. All right, what would you say I should not start with first? I would not try to fix hydrogen. 1, because these 2 numbers don't agree with each other very nicely. I would go with anything that has a 1, go fix that first, because that's going to be easy. Because if there's 3 over here, then I need 3 over here to balance it out. Once I write a number up here, though, you have to fix your totals. So now that gives me 3 sulfates. And how many total hydrogens on the left does that change it to?
6 plus
No.
3, which is 9.
Yes, because this gives me 6, but we still have the 3 here. So 9 total. That's where it gets tricky, is when you have 2 in different places, remember to add them together.
Now you could do aluminum. 'Cause
Good, aluminum would be an easy one, right? Because there's a 1 and a 2, so let's put a 2 here. Because that fixes that one for us. All right. It is, yep, it's messing up the hydrogen again. And that's what's going to happen is sometimes you'll fix one thing and something else will get messed up. But you'll see that it will magically piece together here in a second. All right, so how many, let's see, that changes my oxygen count to how many?
6.
6, because there's a 2 here. That 3 is with the oxygen. So 2 and 3 gives me 6. And now look carefully, how many total hydrogens do I have now? Good, I had some people say it, because this gives me 6. This gives me 6. So a new total of 12.
So then you can put a 6 on the H2O.
Good, so let's fix our oxygen. So that's a 6 and a 1, so that means this just needs a 6 in front, which fixes that. And conveniently, how many hydrogens does that give me now?
6.
Oh, I hope not 6.
We're
We'll be
like,
done.
crap.
12. And then everything is balanced. So on this one, you just put a 1. Okay, it's kind of a back and forth, and then, hey, look, I'm done.
Wait, where'd you get 6 on the bottom for oxygen?
So, it was like this before, right?
Yeah.
And so, since this is 6 and this is a 1, they have to be equal. So that means I need 6 up here because 6 times the 1 will give me the 6 more. The thing, everybody, is balancing does take practice. It's the more you do it, you'll start getting better at it. But in the beginning, it may take you a long time, and that is okay. All right? All right, go ahead and try for me this practice problem on your own. Okay, balance this one out for me on your own, and then I'll walk around and see how we're doing.